Good afternoon, ladies and gentlemen, and welcome to our linear graphing XY plot graphing series. In our video here, we're going to talk about how we graph an XY plot and how we draw a line of best fit. You'll notice here I have a graph set up on the paper. This right here is going to be graph of the density of an object, whatever the object happens to be. You'll notice here I've got two data sets, volume X and mass Y. In this particular measurement, we took various volumes, 10, 20, 30, and so on. This is going to be our independent variable. These are the ones that we control. Our dependent variables, y, are the variables that are going to change. And you'll notice the masses here have different values for our masses. They're not perfectly even. Due to the way the data set is set up, our x-axis here is going to be volume, and our y-axis here is going to be mass. The first thing we need to do is identify what we should label each of our lines here on our graph. To do that, I've created a simple equation. The equation says we should put the highest value from the data set on top and the number of lines on the bottom, and then round to a reasonable number. Generally speaking, we want to have our rounds be to either 1, 2, 5, 10, 15, basically any value, any relationship of 5. Generally speaking, we also want to put a number on each line. For example, if we were going by ones, we would go 1, 2, 3. Let's take a look at how this would function via our two data sets. For our first data set, X, our highest value is 50 milliliters, and the number of lines is 10. That makes this easy, 5 per line. 5, 10, 20, 30, 40, and 50. For the Y, it's a little bit more difficult. I have 63.8 divided by 10 is 6.38. Now, 6.38 is not a very good value. I can go to 10, but that's going to limit my graph to the bottom part of the graph. Generally speaking, though, you almost always run around this up to the 10. So let's go ahead and make that a 10. That means that each of these will be 20, 40, 60, 80, and 100. Ideally, you want to put the numbers on the outside, but due to limitations on space, I'll put them inside. Next, I'm going to plot my data points. I start by locating the first data point, 10, 12.6 on the graph. I'll start with 10. I'm going to imagine a line going up. This isn't actually written on your paper, but it's good to show it here. Next, I'm going to find 12.6 on my graph. You might remember the estimation. Halfway is 15. Then we can break this thing down into 4 individual pieces. 12 is about here. You might notice there is a severe limit on resolution on our graph here. Do your best. Go over. The first data point is there. I'm going to put a light ring around it so we can see it later. Let's plot the next point. 20 and 20.61. Again, about right here. Put our dot. There's our circle. Our next data point, 30. Again, go up. 37, about right there. Again, you can see there we do have a limit on resolution. 40, 50.2. It's a little bit easier. Here's 50. Let's go and go over here. Here's the next data point. And 50, 63.8. Okay, here's about 63. Now you notice our graph does not go all the way to the top, but you want to make it fit the best possible. Now we've got our data points selected. You'll notice they, generally speaking, follow a line. Next, you want to draw a line that best goes through the data points. The way it works is you want to estimate where the line would go. A ruler or straight object helps. You'll notice here that this data point is slightly too high, and this one might be slightly too high. I imaginarily draw a line and I estimate where the point should be. Then I draw a line. Notice there, the line goes through most of the data points. This right here is what we call the line of best fit. Lines of best fit can be challenging to draw, but they simply require practice to get the best measurement. From here, we can pick data points for the slope. Slope will be covered in another video. As always, here's an example of how you draw an XY plot. Thank you for your presence and have a great rest of your day.